Hello, my name is Luca. I apologize in advance for my English. I'm the CEO of OrientDB and the founder of the project. OrientDB is an open source project, but today I will not talk about OrientDB in particular. So I want to take a look to the leading graph databases today and how the main differences between all these graph databases and what's next. What's the next wave of graph databases product based on what we can understand right now. I pick Neo4j as the leader of the graph database space. OrientDB is the second one, and Titan and Cassandra. So in these slides, I will refer to Titan and Cassandra because Titan has a pluggable storage. Why I picked only these three products? If you go to DB engines under the graph rank, you can see Neo4j, OrientDB, and Titan, right? Also, if you get the 451 research report about the skill of people about graph databases on LinkedIn, you can see that there are only, so the three graph databases are Neo4j, then OrientDB, and then Titan, right? But there are tons of graph databases. It can be like a real product or just layer on top of other databases. Also, by reading the report from an analyst, you can see that in the Garden Magic Quadrant, there is only Neo4j and OrientDB. In the Forrester Research Quadrant, I don't know if they call it quadrant, anyway, there is OrientDB and Neo4j. So that's why I've got Neo4j, OrientDB, and Titan. Okay, so of course I know very well OrientDB. I know maybe less other products, so I try to deepen the documentation. So if there is something missing, if there is something wrong, please tell me so the next presentation will be more accurate. Thank you. Okay, let's start from the standards, right? So this morning we hear about standards, and actually there are only 2-3 standards about graph databases, right? So the first one is Gremlin, the second one is Cypher, because we want to be like a standard, and there is also RDF. We can tell that Gremlin is already used by the top 3 leading graph databases. So all OrientDB, Neo4j, and Titan, they implemented Gremlin, right? And there are a bunch of other products that implement this standard. So Gremlin is a really a wide-used standard today. Then there is Cypher. Or today I heard Emil about Open Cypher initiative, and it's cool, but I was unable to find one other implementation of Cypher today. So if you know a graph database with the Open Cypher, please let me know. But I really look into the Google. Maybe Google is not updated. And there's also SparkQL. SparkQL, of course, was the standard for RDF databases, but today, so it was very popular, and today is very popular with the RDF databases. But the top leading graph databases, they don't support it. So maybe you can run SparkQL, RDF with a plugin, with a connector on top of the existing graph databases, but today it's not considered a standard for the graph databases. So Gremlin, of course, is an Apache project under Tinkerpop. So it was a Tinkerpop standard for a lot of time. Now it's been embraced by Apache. Almost every single graph database vendor implemented Gremlin. Some vendors are stick to the 2.x version, but now most of the vendors are migrating to the 3.0, 3 point something. Everybody knows that the main, so the company that was mostly responsible for the standard was Aurelius, and has been acquired by DataStax more than 1 year ago. The last version of Tinkerpop supports also pattern matching. So if you use a Cypher because you like more pattern matching, take a look back to Gremlin because now there are some pattern matching concepts. Cypher is mostly based on pattern matching. It's been created by Neo4j, of course. And looks like they opened the standard because it was a clear move against Gremlin and DataStax to be the standard de facto for graph databases. So, as I already said, after 1 year, there are no implementation. I look for SAP HANA, but there is no mention in any page that they are using OpenCypher. So we cannot say that OpenCypher is a standard today, actually, right? Okay, all the graph databases work in schemaless mode, right? So you can have a vertex, put properties on the edges. But what about schema and constraint? Some databases implement schema and constraint. For example, OrientDB, we have a lot of constraints about property. This property cannot be null, can mean next values, right? Regular expression. We have also inheritance concept we can see later. And you can tell how many edges you wanna for this relationship. Just one, many, one too many. Titan has a good support for constraint, so you can still define that I need that this property is defined. Otherwise, the vertex is not validated, right? And you can tell that this relationship is one to one, one to many. And of course, I support the uniqueness through the index. So I just wanted that one vertex has this ID, right? With Neo4j, it's more basic. You can check just if the property exists, and if that vertex is unique by using the index. Constraint with the graph is something new, right? So we are used to work with graph. You can connect an edge to any vertex, right? So it's up to the application, up to the developer to use the right edge, right? So with OrientDB, we extended the graph constraint. So you can actually say that, for example, has vehicle edge can be connected only from person to vehicle, right? And you can also say just one. So one person can have, one vehicle can only have one owner. You can say that with OrientDB. So you can enforce the schema. Polymorphism. Polymorphism, actually, no other graph databases besides OrientDB are believing the polymorphism. This concept was taken from the object databases, right? Object database paradigm. Polymorphism, we think that is very cool because you can extend the vertices, edges by defining your own classes. For example, I can extend the vehicle, right? With car, motor, truck, and all the subclasses still inherit all the properties from the base class, right? The properties and the constraints in the same way. So, and the cool thing is that I can define that a person can have a vehicle, right? But doesn't matter which actual implementation I'm using. So I can extend my model by creating other subclasses, and all the constraints still works. Of course, the polymorphism works also in the query. This is a SQL because OrientDB supports SQL, but works also in Gremlin. You can set a start from car, so you get all the cars, of course, but you can still query, give me all the vehicle, right? So all the instances from a car, motor, and truck will be retrieved. So all the queries are really polymorphic. What's next? We think that having a schema is very, very important because in this way you can validate your model, especially when you are opening your graph database to third-party application for external users. You want that this kind of relationship can be only between this kind of vertex and this kind of vertex. So we believe that all the graph databases will embrace more constraint on the schema in the next year. Data type. What can you store inside vertex properties, edge properties? With OrientDB, it's super rich. You can have even embedded object, like MongoDB, you can have embedded object inside vertex and edges. We have set, map, all kind of things. Geospatial, polygons, datetime, decimal, because maybe you want to store your salary and you don't want to use a float, right? With Titan, it's still pretty rich. You can have a decimal, list set, so list is an ordered collection set. You can have just one entry at the same time. And polygons. In Neo4j, it's pretty poor, just the basic type. Think that Neo4j doesn't support any date type. You have to store like a long, or there are no support for decimal, maybe in the future. And you cannot have a set, list, collection embedded, right? Okay, this was easy. What about replication? We are getting more hard here. So replication, we can see that these three products, so OrientDB and Titan, they support a multi-master, while Neo4j is supporting master-slave. So with the master-slave, everybody knows this concept, but with master slave, you have this exact same database replicated across a lot of servers, so you can scale up on reads, right? So because you can read from any of these servers. But the write, all the writes has to go on the only master server. So it doesn't matter if you have 100 servers, the bottleneck is still the only master, right, on writes. With the multi-master, all the client can read and write from any servers. So you can scale up the writes much better in this way. Of course, there is a replication cost. If you have 2 servers or 100, every time you write anything in the database, that kind of data, that data has to be replicated across all the servers. So there is a replication cost, of course. If you have a lot of servers, you can have like a huge slowdown because there is a lot under the hood that the databases are doing. And we can say that the more number of servers we have in replication, the more latency of replication we have, of course. So this is with the multi-master, because with the master slave, you just are writing on the master, and you get the acknowledgement from the master immediately, because you don't have to wait for the quorum, right? Because you have just one master, so it's much easier with this master slave. With the multi-master, you can have this problem. So to recap, about replication, both the Neo4j and OrientDB are a strong consistency. So they have transaction, real transaction, ASCII transaction. So you can have begin, commit, rollback. Instead, Titan and Cassandra, every time I talk about Titan, it's always Titan and Cassandra, right? So there is not this concept in Cassandra like real transaction. Of course, all the product can support eventual consistency, so this is the default mode of Titan, but in both Neo4j and OrientDB, you can relax the consistency to be eventual if you want. Replication configuration per entity. This is something that I found only in OrientDB, so you can define that for the class customer, for example, I want to write quorum 3 and asynchronous replication. So you can define per single class what kind of replication you want. I cannot find the same configuration for Neo4j and Titan. So all the settings are global to the global database. But this is becoming more important when you have a multi-model database, we can see later, where you host not only the graph but also other entities. So you want a different configuration based on different use cases in the same database. Cool. What's next? So master slave is too limiting. Master slave is pretty. So all the databases long time ago they were master slave. Now all the new products they tend to be multi-master for that reason. It's more flexible and more scalable. You can tune the consistency, the right quorum. And of course, having something that is tunable per class is even better. I don't think the Neo4j in the future will be multi-master because it will be a huge change in the architecture, but we don't know. Actually, we don't know their plans. Sharding. Both Titan and OrientDB support sharding, but Neo4j doesn't. And for Neo4j is an anti-pattern. So you don't have to, you shouldn't shard your database, your graph, across servers, because of course it's low. But why sharding? Why Titan and OrientDB believe in sharding the database? Easy. When your database cannot fit in just one server, your database is so big that you need to split the database in multiple servers, right? Very, very easy reason. So you can have like 3 shards against 3 different servers. This is a very basic example. And your graph, of course, is spanned across all the servers. So to improve the performance of replication, you can have the replica factor to a value that is lower than the number of servers. For example, I have the first shard, second, third shard. So the first shard goes on the server A and B, the second shard on B and C, and the third one on C and A. So every single shard, every single partition of the database is replicated across 2 servers only. So every server, this means that every server has 2/3 of the database, right? This is the fault tolerant. In this configuration, just up to 1 node unreachable. So if any of these nodes is unreachable for any reason, you still have the entire database in this way, right? But in this way, I can be super scalable with a lot of servers without paying a lot of cost of replication, because the replication factor stays on 2. So every single record is replicated just 2 times, right? No matter how many servers, how many shards you have. This is the only way we can scale up on RISE with the multi-master replication. So in this way, thanks to the sharding, by properly sharding database, I can have a constant cost of replication even if I have 1,000 servers. What about traversal? So the pain with traversal, with the sharded graph, of course, is that you have your graph across a lot of servers. So if you are traversing the graph across different servers, you have a lot of network round trip, right? So the best way to resolve this problem is by using a batch traversal algorithm like a Google Pregel. So you are not crossing the graph for every single connection, but you are batching the traversal, and you do it in just one shot, right? So maybe you traverse like the first 50 relationship in just one batch to the other server, and the other server start with this context, and so on and so forth. So Google Pregel is very popular. You can find the PDF from Google a long time ago, and a lot of graph vendors already implemented this strategy, actually. What's next with the sharding? So the very hard thing is to provide the best algorithm to shard your data across a lot of servers. You can do in a lot of things, in a lot of ways. Maybe you have your graph represents a lot of clients. Maybe you are multi-region, so maybe the client from Europe can be stored in the server of Europe, right? The American client on the American server. So this is pretty easy. And when you have connection between these 2 clients, you can be available to pay this network latency. This could be like a solution, but this is very easy. If you want to have like an auto sharding, so you distribute your graph in a random way, the Pregel-like algorithm helps a lot. But of course, having like a custom strategy is the best thing always. So we are working in something that we believe that also other graph databases are working on. So it's a way that we can provide the way that the user is accessing to the graph. So if I'm traversing this graph always in this way, I can suggest to the user, hey, can we refactor the graph in this way? Because this will be much faster. So we are working on this novel technology, but I think that also other graph databases, they are sharding distributed, they are working the same thing. So in this way, we can actually optimize at the runtime the access to the graph by suggesting the best way to share your graph across all the servers. OrientDB already support the move vertex command, so you can refactor the graph. Of course, it's up to you. So you have to know, okay, maybe I did a mistake. I want to move all these pieces of the graph to another server. So we think that in the future, with the sharding and multi-master replication, more vendors will go into it, and we will see more sophisticated algorithm to distribute your graph across a lot of shards. Security. I'm talking about security a few days after the ransom of MongoDB and now Elasticsearch. I don't know if you hear about this news, maybe all of you. But anyway, what kind of security graph databases provide? The basic user role, fortunately, all the main vendors support this concept, but there are some non-SQL products, different graph databases. They don't even have like a concept of user and password, so they are really accessible. Record level security is a feature that only OrientDB is implementing right now, but you can do the same with if you're using Tinkerpop. You can have a partition graph, so it's an application level, it's not a database, but you can do the same thing. So you can say that against the same class customer, let's say customer, 2 users can see different data because you are profiling the every single vertex per user or per group. Okay. Encryption at rest. This means that when the database actually store data on disk, store data has to store data on disk, right? The data is encrypted by using like a strong password. So in this way, even though your application has a lot of leaks and somebody enter your application, your server, and can grab the database directory, is not able to read any of the content because all the content is encrypted. So this feature is provided only by Titan and Cassandra, only with the DataStax version, so the enterprise version, also OrientDB. Yes, OrientDB, the community version, actually. So Neo4j is not supporting this feature. What about hashed and salted password? We believe it's very important to, even though somebody grabbed your database in any way, is still able to, read all the password. I know the password can be hashed with a super secure algorithm, but it's just a matter of time, right? So it's very important to protect all the password with the salt, with the configurable salt. But this, I wasn't able to find this feature across other graph databases vendors, not only Neo4j and Cassandra, but also other graph databases. So only OrientDB is implementing this feature today. What about Kerberos LDAP? This is not really security, it's more profiling. But if you want to build your database in enterprise with the Kerberos LDAP authentication, you can use OrientDB and Titan. I cannot find something for Neo4j. Maybe it's an external plugin, so I'm not sure about it. So what next about security? Of course, it's very dangerous having no security at all. So if databases create a default user, everybody else should change that password immediately, right? But anyway, if somebody breaks into your application, into your server, and get the database, actually is able to read the database, it shouldn't be possible to decrypt every single password, right? So we believe that encryption, by using salt, is very important in the database nowadays, because it's not the first time that somebody sees the database. I don't know, like a famous company, they crack thousands of passwords, right? If they have like a configurable salt with a hashed password, it's almost impossible or takes years to decrypt that database. So we believe that other graph databases will go in this direction to be more safe, more secure by adopting this simple, feature. Other feature was in the list was the transaction. So only Neo4j and OrientDB support transaction. So for a lot of cases, the base consistency is fine. You don't need transaction, right? But sometimes having a real transaction where you can do rollback or commit, or in case of crash, you restore database before the transaction could be very, very useful. I've seen a lot of times applications that they are using a NoSQL database without transaction support, and they implement a solo transaction at application level. It was very, very horrible way. It doesn't work, actually. Or it's super slow, because you have to write a lot of information while your database can do that for you. Multiple databases per server. If your application needs more than one database, pay attention to the vendor that provides you the possibility to create multiple databases on that server. We found this feature in both Titan and Cassandra with the key space, and of course OrientDB. In Neo4j, one server supports just one database. So if you need 3 databases, you need 3 servers. And if you're using the Enterprise Edition, you should pay 3 servers, right? So pay attention about your use case, how many databases you need. Because this could be very relevant when you go to production, you actually need these databases. Polymorphism, we already talked about polymorphism, but only OrientDB is supporting polymorphism. I don't know if the other graph databases are going into it. Polymorphism is an old concept, so if they didn't implement it so far, I don't think that they will implement this in the future. Cool. So graph databases, actually, we've seen that they are evolving in something more enterprise, right? So the first version of graph databases, they are very, very simple products. Also other NoSQL databases, right? Maybe it's a key value, just is cool for doing just maybe cache or some very simple use case. But now we are seeing that a lot of NoSQL products, a lot of graph databases are going into be more enterprise. Why? For this reason. This is from Gartner. Most of the big data projects in this year will fail. Why? Why will fail? Because of the complexity. Polyglot persistence was awesome in 2009. We can use the best database for your use case. But when you have a complex application like a booking.com, something like a booking application, you need maybe to store transaction, you want a rational base because it's able to store transactions. But you want to, when you present your hotel, maybe you want to present to the user, oh, maybe if you like this, you can also like this. And in these graph databases, of course, are the best solution ever because Traversa is super, super fast, so they are already super used. Maybe you want a catalog, so a catalog with a lot of embedded parts, so maybe you could use like a document database, right? Like MongoDB, you can embed a lot of information in just one load, you get all the information. You need like a Google-like in your application because you want that somebody can look to the hotel, but just using the search input text, right? So you need something like Elasticsearch or Solr that is looking into all your data. And then maybe you want that all your session, you want that everything is super fast, so maybe you put like a cache in front of your application, or want to just store like the session data of users. And maybe you use like a Redis, like a super, super fast key value. So your application is getting more complex than, I don't know, 6 years ago, 10 years ago, where you just have one choice, the rational base. There is no standard between all these products, even in the same category, like between MongoDB and CouchDB, there are two document databases, there is no standard. They are completely different, right? Different query, and different way to do things. So it could be very expensive, even for Donflam. Especially because the complexity is huge. So we've seen a lot of projects that they underestimate the complexity. They start with, I can use like all these kind of data framework to be the super scalable solution. Then they run out of budget for this reason. Today it's very hard to pick the right technology because there are so many. And you need multiple skills in your project because maybe you are an expert on Neo4j, but you don't know anything about Elasticsearch, for example. So maybe you need multiple skills in your company. So that's why it's super, super expensive. So this solution, in our opinion, is the multi-model. The multi-model is evolution of the actually graph database, but we can say from every other NoSQL category. So with the Polyglot persistent, I picked the right database for my use case, right? With the multi-model database, in theory, I should have a database that is so flexible, so powerful, that can handle all different use cases in just one place. So if you want to explain the multi-model concept, we can say that it's like the intersection of a lot of models altogether. This is an example of OrientDB, so document, graph, key value, full text search, spatial, and object-oriented concept like inheritance, polymorphism, and reactive, because you can also use the database in reactive mode. So if you like the quadrants, we can represent a multi-model as the maximum complexity of relationship, like exactly like the graph database, and the best of complexity, the maximum complexity as data complexity, like the document database, because you can have like a super rich kind of types, collection set, you can embed stuff, right? So it's like pretty much the same like a document database. We can see still the rational base was, is in the middle. That's why maybe rational base lasts for so many years, because actually it was a very good compromise between the complexity of data and relationship. So for example, if you want to design a booking application, right? This is of course a super simple domain. I have a user, of course, with the session, with the live session. I can do orders about products, so I can buy this hotel for 5 nights, right? And I can have like reviews. So I like this page because they have so many reviews. They are all, all great. So with the Polyglot approach, I should split my database, my domain, in different databases, right? So maybe the user is the only thing that is in common between all the databases. So the user has to be replicated across all the databases and synchronized. By the way, there are no tools that can do the synchronization for you. It's up to you. You should write ETL to move data between databases, or is the application that when create like a new user, create a new user across different databases. For example, I could access to the review. Review needs to be aware about the product, right? So maybe I can store the reviews on Neo4j, and all the reviews as to have the information about the product they are reviewing. So all this data can be spent across different databases, different kinds of databases. So with the multi-model, of course, it's much easier. It's just one database that can handle all data for you. Of course, you can do this also with like a key value. You can use a key value for everything, right? It just or a relational base to store all your content. You can go back to relational base, right? It's just that with just one model, you have to force the other model to fit in the original one. With a multi-model, you have different phases of the same data. Cool. So multi-model, who already heard about this multi-model concept? Okay, cool. So what about the history? That's the history. OrientDB in 2010, we believe so badly in this concept that we were the only vendor that having like a graph database engine, but allowing different perspective of the same data. We were pretty much alone. And for a lot of time, we were the only vendor to be multi-model. And actually, this was pretty hard at the beginning because people wasn't looking for a multi-model because they didn't know that they needed multi-model, right? So we try to place OrientDB as a graph document database. So people they are looking for a graph database, they can find OrientDB, and people that are looking for a document database, an alternative of MongoDB, they can look for OrientDB, right? But after March of 2012, I presented this concept in the NoSQL Matters in Germany. Was a keynote, and I explained the multi-model concept for the first time. So was the first time that the word multi-model was associated, was related to the database world. And after 2012, we can see that today a lot of leading database vendors are becoming multi-model. For example, the same DataStax announced to be multi-model, and the last version actually is a multi-model database. So DataStax 5.0 is a multi-model database. They acquired Think Aurelius, so the company that was behind Titan, and so they improved the DataStax product to be also a graph database, right? But it's not just a graph database; it's a multi-model, so you can use a custom in different ways. The same with MongoDB. So MongoDB already announced a long time ago, oh, we will become multi-model in 2016. And actually, they did it. So the last version 3.4, a few days ago, they announced multi-model don't write. So multi-model now is becoming very popular, right? There are two kinds of multi-model, only two kinds. The native engine, so you design your database to be multi-model in the core, in the engine, right? Or you can create just layers. So you can allow like your key value or your document database, and you put like a graph layer on top of it. You can think that, oh, this is a multi-model because I can use a key value and graph. Actually, it is a multi-model. It's just a multi-model in different way because it's using the layers. Why we matter about layers? Because, of course, every layer is a transformation, is a cost. So every time you pass through a layer, we have a slowdown in performance. While the native engine is directly capable to understand all these models at the same time. What's next about this multi-model? We believe that the multi-model database are the natural evolution of the NoSQL product in general, or we can say also the graph databases. So we can represent NoSQL Wave in 2009 as a NoSQL 1.0, and the multi-model we can call, somebody is calling NoSQL 2.0 Wave. So a new wave of NoSQL products, so they are not relational, they are still NoSQL, but they have more enterprise feature. They are able to be more versatile. So we are sure that more NoSQL vendors will follow this wave, and they will announce to be multi-model this year and in the next year. We are pretty sure. Thank you. Wow.
Does Orient have search?
Yes.
Lucene?
We have Lucene integrated.
So you're going towards Solr?
We use Lucene under the hood. We don't use Elasticsearch Solr, we just Lucene. So the engine that is used by Solr and Elasticsearch.
how do I interact with, so I go through
Is
the
a
advantage of this?
is integrated in the, so you can use this OrientDB supports SQL also brand name, but also SQL. So you can use the SQL like it was a normal index, and OrientDB will use the Lucene index for you. So it's transparent for you. But you can use Lucene directly if you want it. There are the API to interact with Lucene by using the Lucene syntax. That sometimes it's more powerful.
So in your presentation, when you referred to Titan and Cassandra, are you referring to data stacks, or are you referring to kind of what you knew about that before data stacks kind of took all that?
Before, yeah, what was before? So even though data stacks DSA could be similar to Titan and Cassandra, of course, but today is not popular. So I cannot see any client in production with data stacks DSA because it's too new.
Okay.
So when I pick the leading graph databases, I cannot get data stacks because it's not still popular. But maybe next year we can analyze the differences with data stack DSA if it will be used in production.
Who are the top customers you have?
Sorry?
Top customers where implemented?
Top customers, usually with the presentation about OrientDB, I have a slide. So the top customer that maybe are very known in America could be Apple, Exxon, VeriSign, Barclays, Ameriprise. So all these Pitney for example, is in Austin. So a lot of clients are using OrientDB, especially in the Fortune 100. And we have 1,000 startups because OrientDB, I wanted to remember that OrientDB is an Apache license. So you can use OrientDB for any purpose. The community edition. If you want something more, you can use it enterprise, so it's commercial. But everything that you've seen here, you can use it with the community edition. So it's free for any usage. Apache license.
What do you have to say about read and write performance for your DB? Seems like they're comparing here Titan, Cassandra, and then Neo4j and OrientDB, and then this explain the Polyglot architecture to Neo4j is more about query performance on graph. It's awesome,
Right.
but they don't scale out. Titan and Cassandra, they scale out. Insert performance is awesome. So where does OrientDB stand in that?
Yeah, that's a good question. We have the embedded version that is very similar to Neo4j, so you can embed OrientDB in the same JVM of the application. So we avoid completely the TCP IP network. And of course, it's super fast. In some benchmark, we are faster than Neo4j. In other benchmark, like massive insert, especially at the beginning, we are slower usually. We know that. But Traversal is comparable. We have, you can find the IBM Tokyo benchmark. It was a few years ago. I compare Neo4j and OrientDB on this, and you can find online. It's IBM Tokyo and Tokyo University something. About distributed, we work a lot. So Cassandra was more mature than OrientDB in distributed. So we work a lot because we are not using any other product, right? We use Ethercast at the beginning, and now we are using less Ethercast. Anyway, we are working hard to create super scalable databases, and we have the first benchmark with Cassandra, and the performance are comparable. So you can use, if you use the classic massive insert query, you can have pretty much the same throughput. There are some use cases where OrientDB is faster, some other use cases where Cassandra is faster. But I can say they are comparable. But don't believe in benchmark, just use by yourself. You can try it and you can decide.
So sometimes a multi-model claims that you can pretty much run all workloads, which essentially I have a contention with. But the point is the relational databases have tested with TPCC and TPC-DS and those kinds of benchmarks. And so if you were to support all those workloads, if you promise to, then you should perform well in those benchmarks as well compared to relational technology. Besides the fact that I would like to know if there are standard graph benchmarks or benchmarks that sort of span the workloads between graph and relational. So
Yeah, there are not so many benchmarks against the graph databases. Now there are a couple of initiatives to make this benchmark standard, but that's a good idea. So we could measure ODB against the classic TPC benchmark. That's a very great idea. So we can compare ODB against other relational databases.
There is, but the linked data benchmark, LDBC.
Yes, that's one of the two initiatives.
LDBC, I'll be giving a talk in the afternoon, giving an update, what the linked data benchmark council has been doing in the draft tool. That is, they're supposed to be the TPC of graph databases. They already have benchmarks for social networks.
Yeah.
They have 3 social networks, 3 benchmarks already published, results and stuff, and new data.
Well, and then certainly, I think the point I was trying to make is certainly that's valuable to have a standard benchmark for graph. But at the same time, if you're promising to, have multi-models where you're trying to support all workloads,
That's right.
then the question becomes, do you
That's
really have
really-
a benchmark that you're
That's
assessing?
the bigger problem.
Yeah.
And a multi-model benchmark, the best of my knowledge is not.
Right.
Yeah,
So you sort of have to have a meld of these things.
that's a good idea. Any other questions?